All right, this video is going to talk about how to use factoring to solve quadratic equations, or an equation where there's an x squared or a variable squared in your equation. This video also kind of assumes that you already know what factoring is. You maybe solved some theoretical factoring problems. We're going to try to use it and show you where we can apply this. So a simple geometry approach. The Parthenon in ancient Greece, so you got the building over here at the right, the ruins there, is a structure with a rectangular base. So we've got the rectangle drawn to the right here. The length of the base is 8 more than twice the width. So let's say we just call the width x. We know that the length then is going to be twice the width, and again 8 more than that. So I'm going to go ahead and say 2x plus 8. Again, you could also say 8 plus 2x. The area of the base is also 2,170 square meters. So we have two ways that we can represent that area. So if we want to find the length and the width, what we need to do is sort of work our way through that area idea. Remember that area of a rectangle is just length times width. So we could say that it's x times 2x plus 8, right? Length times width is equal to the actual area that we know. And here's where the factoring comes into play. If you take a look at it, we're very tempted to distribute there, and I'm going to go ahead and do that. I'm going to distribute my x to both parts, so this becomes 2x squared plus 8x. And while we're at it, we would love, if we're going to have that x squared that we just found, right, we would love to be equal to 0. Thinking about factoring, being equal to 0 is very helpful. So what I'm going to do is go ahead and subtract 21,000 or 2,170, right? 2,170. I'm going to subtract that from the left side, and I'm also going to subtract it on the right side of my equation, which basically just leaves me with 0 there. Now we've got a quadratic equation, or an x squared equation, right, with another x in it, right? We've got these two terms here, but we're equal to 0, so this is a great time to factor. It's a great time to factor. Now, I also notice, now I could start this and do a larger method, if you know the box method or the swing method, or maybe a grouping method of doing this. We could factor from where we are, but the best idea, remember, is always to start by factoring simply. Is there anything in all three of those parts, in that x squared, that linear x to the first, or that constant, right? Is there anything in all three parts that I could factor out? And since it's just a number, I'm actually going to go ahead and divide out a 2. 2 goes into all three of those, so I can divide on both sides by 2, and we'll have x squared plus 4x minus, and for that I'm going to go ahead and use my calculator. 2,170 divided by 2 is 1,085. Now that's still a pretty big number, but it's slightly smaller, and because now it's only a 1x squared, I already know if I'm going to factor this, that I'm just going to have x and x, and I can use some of my good old-fashioned solving methods here. I want to add to the middle, and I want to multiply to the end here. If I can find two numbers that multiply to negative 1,085 and add to 4, then I can factor this apart. Go ahead and pause the video now and see if you can't come up with two numbers again that multiply to a negative 1,085 but that add to 4. All right, if you found your two numbers, hopefully what you found was 35 and 31. They multiply to 1,085. And because I want to multiply to a negative, I know that one of those is a negative number. But because I want to add to a positive, that smaller one better be the negative number. Right? 35 times negative 31, though, would multiply correctly to negative 1,085. And would add correctly to 4. So what I'm going to go ahead and do is write those in to my problem here. And if I FOILed or distributed that, those two binomials back together, it should take me right back to that trinomial. However, now that I'm multiplied and equal to 0, now we can say that x plus 35 could equal 0, or x minus 31 could equal 0. Two things multiplied equal to 0, one of them has to equal 0. One of them had to be 0. So x could be either negative 35, right, if I subtract that from both sides there, or if I add 31 to both sides of my other equation, x could equal 31. Now, because x is the side length, right, it's the width, It definitely can't be a negative 35. So what we call this is extraneous. It's an extraneous solution, EXT there. Not going to work. Doesn't make sense in the real world, right? Won't work with our answer. So our answer is going to be 31. But now go back to the question that they're asking. They want us to find the length and the width. Well, x was the width. So the width will be equal to 31. And notice we're in square meters here. So 31 meters for the width. But remember that the length, right, was 2x plus 8. So the length is 2 times that 31 plus 8. And basically the length will be equal to 62 plus 8 is 70 meters. So again, the base of the Parthenon must have been 31 meters by 70 meters. And that's a good answer there. Now, if you can solve an equation moving forward, one other thing that we can do, just a little side note here, is we can take numbers and we can try to write equations that would have these solutions. Now, normally that's not real hard to do because we would say, well, hey, if x equals negative 5, then I must have an equation if I add 5 to both sides that x plus 5 equal to 0 would be a good equation, would have an answer of negative 5. We could also do that with the 8 and say x minus 8 could equal 0. So x, again, if I add the 8, x equaled 8, right? Right there. So if I go ahead and subtract 8 on both sides, sorry, I got ahead of me here, would equal 0. And we've got another equation there. Well, if we want a quadratic equation or a standard polynomial equation, right, with those two solutions, remember, if they're both equal to 0, then we can say, well, hey, if x plus 5 multiplied by x minus 8, if either one of those was 0, well, multiplying them means we're equal to 0. And if we want standard form, it's just a matter of foiling. X times x is x squared. We would have a minus 8x and a positive 5x, right, outside and inside. And then last would be negative 40. And x squared minus 3x minus 40 equals 0 is a good standard form equation. Well, notice what really happened was minus 5 became x plus 5, and 8 became x minus 8, right? We kind of had to change the sign there. So if we wanted to shortcut it a little bit on the right here, what we could say is x, well, since that's a negative 1/4, let's call it a positive 1/4 right there, could equal 0, right? And at the same time, x minus 2/3, right? If I put 2/3 in there, that would equal 0. Well, the nice part, the real key is if we don't want any fractions in our final answer, remember, we can multiply 0 by anything we want, and it's really not going to change anything. So why don't we multiply both sides of this equation by 4, because then we get a nice 4x plus 1, and on the other side it's still 0. I'm going to do the same thing over here. I want to get rid of that 3, so I'm going to multiply both sides by 3. This becomes 3x minus 2. 3 times 2/3 is just 2 equals 0. And in that case, 4x plus 1 times 3x minus 2. And if we did a little bit of, again, foiling, 4x times 3x is 12x squared. On the outside, we get a minus 8x. On the inside, a positive 3x. And again, last would have been 1 times negative 2 is negative 2. So 12x squared minus 5x minus 2 equals 0. And I will guarantee you, if you plug negative 1/4 in there or 2/3 in there for x, that you will get 0 back when you're done. I hope that helps you. Again, working with those polynomials a little bit. If you have any questions, talk to your teacher. Otherwise, have a great day.